Hi everyone, welcome back to class of inferential statistics. On previous lecture, we already know how we want to construct the statistical test. As we know, we have subset C where we denote for rejection region, and then we have a complement C prime as the acceptance region. So if our experimental values belong to C, then it means that we shall reject the null hypothesis. Otherwise, if the data set or the experimental values belong to C prime, we shall accept our null hypothesis. We already discussed on the first example and also the second example. So in our first example, we have a normal distribution with mean theta, variance is 100. We want to test theta equals to 75 versus alternative is theta is greater than 75. We use number of sample size n is equals to 25. So we already find that the power function is probability rejecting H0. So we have probability x bar greater than 75. So we already substitute for theta equals 73, 75, 79, and also theta equals to 77. For testing the theta equals to 75, we got the probability is equals to 0.5. So that's mean the probability of rejecting H0 when H0 is true in here is half. So many statisticians and research workers find it very undesirable to have such a high probability as half assigned to this kind of mistake. So in this case, test 1 does not appear to be a very satisfactory test. So we proceed with second example where we have theta now is equals to 78. So our power function of the test in this case is probability x bar greater than 78. So we repeat the same procedure. In this case, when we compare when H0 is true, theta equals to 75, we got the probability is 0.0668. So that means if we reject the null hypothesis when H0 is true, we only have a smaller probability compared to the previous test. Okay, so in this case, compare test 1 and test 2. So test 2 is better than test 1. But when we consider theta equals to 77 and also theta equals to 79, since our alternative is theta greater than 75. So in this case, reject H0 when H0 is false, theta equals to 77. In this case, we have the probability is 0.3085, which is quite smaller than our first test. The same thing if we have theta equals to 79. We get probability is just when reject H0 when theta is equals to 79, we have 0.6915, which is smaller than we get from the previous example. Okay, where we have theta equals to 79, we got 0.9772. Okay, so we might question that test 2, in this case, our test 2 is not wholly satisfactory. So perhaps we can overcome this by try the other test. Okay, let us consider the third example. So in this case, we will have a power function k3 theta. We have theta equals to 75 and also theta equals to 77. So we already have the probability is 0.159. For theta equals 77 is 0.841. So we like to find the value for C and also N. So we can write that our critical region is equals to C is equals to summation Si greater than N of C. So we will have x bar greater than C. So this is the power of the test. So now we want to find probability x bar greater than C. So we have x bar minus theta over 10 over square root of n greater than C minus theta over 10 over square root of n. So we will have probability z greater than C minus theta over square root of n. Okay, given that we have k3 with theta equals to 75 is given as probability Z C minus 75 0.159. Okay, next we have K3 77 probability Z greater than C minus 77 over 10 over square root of n is equals to 0.841. Okay, let's say we refer this one as Z alpha. So we can write Z greater than Z alpha is equals to 0.159. So we take approximate value, probability, so we have 0.16. From our stats table, the value of Z alpha is given as 0.9945. So we solve this problem. So we have this equation. Let's say we denote as the first equation 1. Okay, next we have C minus 77 divided by 10 over square root of n is 0.841. Okay, so the same criteria. So let's say we have C minus 77. So 0.841. Okay, let's say we want to find probability Z greater than Z alpha 0.841. Okay, so since we want to find Z greater than Z alpha, which is 0.841, so that means our Z alpha should be on the negative side. So then we will have the probability is 0.841. So we take the balance, 1 minus 0.841, we get 0.159. So in this case, Z alpha will be negative 0.9945. So the same approach, we solve the problem. So C minus 77, 10 over square root of n equals to minus 0.9945. So then we get C minus 77 negative 9.945 divided by square root of n. So this one is the second equation. Okay, so by solving the first equation and also the second equation, so let's say the first equation, let's say our first equation minus the second equation. Okay, first equation minus second equation. So we'll have 2 equals to 19.89 over square root of n. Okay, so that's mean the first equation C minus 75 equals to 9.945 divided by square root of n. So minus C minus 77 equals to this value. So we simplify, we'll get this one. So n, we compute n, so square root of n 19.89 divided by 2, and then n will get approximately 99. So using n, substitute in either equation 1 or equation 2, then we will get our C value should be equals to 76. So in this case, for the third test, we have a large sample size where we have n equals to 99 and also large critical region, which is we have the value C is equals to 76. Okay, we have theta equals to 73. So we proceed with z greater than 76 minus 73 divided by 10 over square root 99. So this will give us, if we standardize, we get z greater than 2.98. So from our stats table, it gives us 0.0014. Okay, next we try to compute for theta equals to 79. So we will have z greater than 76 minus 79. So standardize the value, and then we have z greater than minus 3. Z greater than minus 2.98. So same thing, if you have this one, compute from your stats table. So in this case, we will have 0.9986. So if we compare these two probabilities, we know that our H0 in our first case is theta less than equals to 75. Our alternative is theta greater than 75. So when theta is 73, so that means we reject H0 when H0 is true. Our probability is smaller, which is 0.0014. When theta is greater than 75, which is in this case is theta equals to 79, okay, so we reject H0 when H0 is false, is we give the probability is 0.9986. So from this test, we know that it says that test 3 has a more desirable power function compared to the test 1 and also test 2. But again, if we look at this example 3.3, a certain price has been paid. In this case, we need to use a sample size of n equals to 99. Compare that we use n equals to 25 in previous tests. That means higher sample size, it gives you higher power of the function of the test. But overall, it depends on the researcher, either they are willing to use more sample size or they want to use a small sample size. Okay, so that's ended our 3 example, as we want to show that the importance of the power function of the test is depend also on the value of theta and also the value of sample size.